Hello, my name is Julius, and I will be going over some chemistry concepts with you today. Right now, we'll be looking at how to properly draw the VSEPR diagram. First, we will start by taking a look at the atoms that compose our compound. Iodine trichloride is composed of 4 atoms, 1 iodine and 3 chlorine. We will begin our drawing by placing our iodine in the center of our diagram and attach the corresponding chlorine with dashed lines, a straight bar, and a drawn-in triangle to mark the spatial relationship to the central iodine, while not forgetting to include our lone pairs of electrons here and here. And be sure not to forget to include the remaining electron pairs for your surrounding atoms. You will notice the structure of the VSEPR diagram is very similar to the Lewis-Dot structure of iodine trichloride, which is only really different in the fact that it shows orientation of the chlorine atoms in relation to the central iodine atom. By using the dashed lines as seen here and the forward bar here, the lone pairs of electrons in this molecule alter the shape a tad by forcing the arms of this T-shaped structure downwards. So your overall angle up from here to here will be less than 180 degrees. And between the chlorines it will be less than 90 degrees, giving this molecule its particular shape, which is trigonal bipyramidal. Trigonal bipyramidal, still also called T-shaped, even though its arms are slightly bent downwards, where we will go over the box diagram for iodine trichloride. In the box diagram, we will start by taking note of the valence electrons of iodine, our central atom. As you can see here, I've already drawn out the appropriate boxes for the valence shells of iodine for both the ground state, GS, and the excited state, ES. And now I will show you how the valence electron positions change between these two states and how they change. So, iodine has 7 valence electrons, and we will fill our ground state shells as so. And now, to promote a ground state electron to its excited state by adding energy, like so. Adding energy, taking 1 electron and exciting it to a higher valence shell, like so. Jeez. Not forgetting our remaining lone pairs, our unpaired electron, and the lowest shell lone pair. From here we will go through our hybridization stage, where we will show the pairing of all the electrons present in this molecule. We start by labeling our lone pair electrons from the iodine atom. And our sigma bonded electrons between the iodine and chlorine. This specific hybridization is sp3d. Named such due to the overlapping s, p, and d orbitals provided to this molecule by iodine. Now to go on to the next slide, where I will show you how to draw the contour diagram. As you can see here in the top right corner, I have shown a picture of a reference model of this molecule. And now we will begin to draw it. First, we will start by creating our reference lines, like so. These will help us put our chlorine atoms and the displayed overlapping bonds in the proper places. So first we'll start by attaching our iodine to this frame, and then draw our orbitals as such. There is one orbital, another orbital, here we are, and these are all sp3d. D. Now we will attach our bonded electrons and include the overlapping chlorine orbitals, which are 3p. Here we go. There is one chlorine. Here is another. And our last chlorine. Now to include our lone pair electrons, which are also sp3d bonds. Whoops. Here we go. And there. sp3d. One pair, two pairs. These are all sigma bonds. The symbol for sigma is this. Bond. This molecule is still trigonal planar. with a T-shape influenced by these two lone pairs of electrons attached to the iodine atom, which decrease the space between the chlorine atoms to less than 90 degrees. And this will conclude our short tutorial focused on the structure of this molecule, iodine trichloride.